Welcome, dear viewers, to another episode of What's New in Prisma, the show where my colleague Daniel and I are talking about the latest news from the Prisma ecosystem and community. Hello, Daniel. How are you doing today?
Pretty good. Yeah, can't complain. I think this is starting to be one of the shortest days of the year. So just getting cozy in here. Got a mug of tea.
Yeah. Well, at least we had a little bit of sun today in Berlin, right? So that was nice for a change. All right. I would say that we don't lose too much time because we have a packed agenda today. So we will talk about the release, of course, the 3.6 release that happened on Tuesday, but we'll also dive a bit deeper into some of the things that we have released. For example, the improvements to the VS Code extension using WebAssembly that you also wrote a blog post about. So we'll dive a little bit into that. Then we'll have one of our Prisma ambassadors as an exclusive guest on the show today to talk about a project that he has been working on, a Prisma schema builder. So a visual UI, a tool that you can use to create your Prisma schema in a visual way rather than typing it out in your editor. Then we want to present a feature concept for the Prisma data platform that what we also talked already about in the keynote of the Prisma data serverless conference. And finally, we want to catch you up on a few things that are happening in the Prisma development by looking at our public roadmap. So let me go ahead and start by sharing my screen and walking over the release notes as we usually do here on this show. So the stream is down there. Let's bring it up to the stream. Here we go. So 3.6 is the latest version number, and we have a few improvements that we want to share. For Prisma Migrate, so this time we separated the new features and improvements according to the tools where they happened. So for Prisma Migrate, we introduced full text index support for MySQL and MongoDB. That's in preview. So it's not quite yet ready for production use, but we still want to encourage everyone to try it out and share their feedback on GitHub so that we can make it production ready faster. We also introduced hash index support for Postgres. That's also in preview. And I think on both of these, or for like kind of comparison, what they actually mean, you prepared a little bit of information, Daniel, but I think we'll save this maybe for when I'm done with the release notes.
Yeah.
Then there also is the improvements to the VS Code extension that now uses a WebAssembly, short WASM module. And that's also something that we'll dive deeper, so I'll just skip this in this quick overview as well. In Prisma Client, we also have a couple of improvements. So the bytes type, which is a data type that you can define in the Prisma schema, or rather use in the Prisma schema for the fields that you're defining on your models, you can now filter this with the in and not in operators. So we're just expanding a little bit the capabilities of Prisma Client and saving you from some overhead for these kinds of rather edge cases where you might have to drop down to raw SQL. So this is now possible with the native Prisma Client API. Similarly, we improved the handling of JSON fields that now accept read-only types. I really like this phrasing by our product teams that have been putting together the release notes, small quality of life improvement for people that are using this feature. Again, these are the small features that maybe are not super relevant for the majority of users, but I think for those that are using this feature, these kinds of improvements are really appreciated. Then there are just a number of smaller fixes. So we reduced the interactive transactions timeout for the binary engine. Again, probably something that's not relevant for a lot of people, but for those that are using the interactive transaction API, currently for those that will be quite relevant. and there was an issue with not in filters for large queries. That is now also fixed. All right, that's it already with the overview of the release notes. So Daniel, why don't you go ahead and share what you have prepared to talk about the indexes?
Yes. Okay, so let me just bring up my screen. Great. Yeah, so now we're basically, let me just go back here. Yeah, so we're basically introducing this new hash index support for Postgres. And I thought it might be good just to do a quick overview from a high level about the differences between the default kind of index that you create with relational databases. Typically, that is a B tree, also known as a binary tree. And now we're introducing this hash. So some of you may be familiar with these two different data structures, from Computer Science 101. And I thought I'd just do a quick run through the differences between them. And so we can probably start with the complexity of these two data structures. And for this, we're using this big O notation, which is a way to sort of represent the complexity of certain operations in different algorithms. In this case, we care about really being able to look up data quickly and insert data quickly. So before we sort of get into the actual complexity, when you have an index, even if you just have a primary key and you insert a record to your database, then usually an ID will be created, and it will actually need to add that ID, that new record that has been created, into the index, the primary key index. And that is, of course, by default a binary tree. And so now we're introducing this hash. And so hash is really nice for looking up single records and for insertion and deletion, because the complexity is just constant time. It just has to do a single hashing operations in order to find the pointer to where the record is in memory or in storage, whereas a binary tree does it within log n, which is sort of one step up in terms of complexity. However, where it gets interesting, and this is probably worth pointing out, that really like hash-based indices are really useful when you're doing equality selections, whereas a tree-based index is good for range selections. And I also have visualizations for what these two structures look like. But yeah, maybe we can go into that. And so here we have a hash map. And the idea here is that you have these indices, and then in order to get the actual index in the hash tree, in the hash map for a record, then you just sort of hash the ID, and then you get the pointer to memory, as I mentioned. And then if you have a collision, then you might have multiple records. But because these aren't sort of sorted in a way, you can't sort of select a range. And so if you do an operation on a column that, or if you filter in a query, in a Prisma client query, based on, say, a date range, and that date index, that date field has a hash index, it will likely have to actually do a full scan and go through all of the different records in this hash map. Here below, we have what is known essentially as a binary tree. This is actually has three sort of records per leaf, and I won't get into the details, but the idea is that actually this is a pretty bad example. But the main idea is that you can sort of select a whole range, and as you can see, the numbers here are going up. And so if you want to get all of the records that are below 5, where my cursor is, then you would sort of take a left turn, and then you would be able to get all of those records. And so I'm sorry, this is probably isn't the best visualization of a binary tree, but that's sort of generally the idea. And so again, to sum it up, hash-based, good for equality selection. It's a bit faster tree if you're selecting ranges. And I should point out that in this case, we only support it right now for Postgres, even though I believe MySQL also has hash indices. So stay tuned, and we might add that for MySQL too. And sort of moving on now to this whole refactor that we did with the VS Code extension. So I think at this point, if you've been using Prisma, you're probably familiar with the VS Code extension. the Prisma schema is really like one of the main touch points that you have when you're working with Prisma, and it is where you define your data model, and a lot of things sort of propagate down from the Prisma schema. Prisma client is generated for you and all of those types, and also these migrations that Prisma Migrate generates for you. And so a little bit about what it does. And so there's a lot of different functionality that goes into these plugins, besides defining sort of the grammar on the language so that VS Code can do the highlighting, and it can do that irrespective of which theme you have. So if you change theme, obviously the new theme will also reflect and do the syntax highlighting. There's also formatting where it really sort of helps you as you sort of edit. There's also a configuration in VS Code where you can sort of automatically do it on save. And if you're like me, where you grew up with computers that had floppy disks and whatnot, then you might have this constant paranoia or angst that you will lose this document that you've been working. So I still have this trauma, and I obsessively Command S is like, yes, it's my safe space. So anyways, you can configure VS Code to automatically format it when you do that. Linting and auto completion. And so first of all, linting, you can see when I'm typing a type that is invalid, it shows the squiggly lines. And also if you do the control space or whatever your VS Code is configured to, then you will get the list of options. And then we have quick suggestions. And so this is a nice example. Let's wait for it to start from the beginning. Okay, so here I'm typing this new comments field, and then I'm giving it a type comment, but because comment isn't a type, it's asking me, oh, do you want to create a new model? So it created a new model for us. And the cool thing is that I just run the formatter and it automatically populates the back relation field, and then I just rename it to match. And then we also have jump to definition. And so here, I believe I'm using my option or the command button. I don't know. I'm just sort of remembering it, and then clicking on a symbol. In this case, it's a model type, and it sort of jumps. And you can also see that when I do that, it also shows us this comment. And so the notation in VS Code for these comments is using 3 forward slashes. And so what's really interesting is how this all works. So many of you are using VS Code, and VS Code has actually revolutionized in many ways a lot of things around, editor, code editors, and they sort of came to this realization that, hey, we want to be able to, we want to allow developers to sort of build their own language-specific extensions. And so you can imagine you have maybe a Markdown formatter, a JSON formatter, maybe even some kind of like ESLint if you're, linting your code. So you can do a lot of different static code analysis using all of these dedicated tools that might not actually even be written in Node.js. And so because VS Code is sort of built, its main runtime is Node.js, they sort of built this protocol called the language server protocol, which essentially allows you to sort of run all of these background sort of processes that might be actually CPU heavy, because imagine if you take in code as input, you have to pass it, sort of construct an abstract syntax tree, and then from that syntax tree, you can start running all sorts of rules to check the validity of that abstract syntax tree. So you can detect things like, first of all, syntax errors. I mean, you probably wouldn't be able to form an abstract syntax tree if there's sort of a typo, but you can do a lot of sort of advanced things once you have this abstract representation of the Prisma schema. And so this is what we do in the background. This is how we're able to tell you, this is invalid, or you need to define the relation field, or this type doesn't exist for this database, and so on. And what's great about this language server protocol is that it's sort of standardized in a way that you can now sort of build all of these language-specific helpers for multiple editors. And so now you have editors like NeoVim, Emacs, and Atom that also support this language server protocol, which means that theoretically you can use these plugins. I mean, you have to repackage them and sort of create some kind of binding, but we have that, I believe, already for Emacs and for NeoVim, for Prisma users, that is, so that they reuse essentially this language server component. And so we are a Rust shop. A lot of you know that, our Prisma engine is built with Rust. And typically, if you want to distribute Rust code, unlike Node.js code, where essentially you just upload it to NPM and then anyone can download it and use it, and all you upload to NPM is just JavaScript code. With Rust, essentially, it compiles to binary format. It's and because it's a compiled language, and because it sort of compiles to a binary, that binary is specific to a specific operating system and CPU architecture. And so that means that, for us to support all of the different operating systems, Linux, different distributions, ARM, Mac, PC, and so on, we have to, I think, generate about 26 binaries, build and distribute all of these binaries. And not only that, we saw a whole cluster of errors that users were experiencing with the VS Code extension. And this is what it looked like until this change. So we had Prisma Visual Studio Code, and you have this extension. And then when you want to do sort of language specific stuff, using this language, the language server, essentially you're running this in a separate process. This is a standard way to do this. But because this other process was a Node.js process and we needed the binary, we had all of this additional logic to download the binary and then also execute it. And that would be another child process. So can you imagine you're just sort of opening VS Code to work with your VS Code on your Prisma schema or your project, and you suddenly have these two processes that are running in addition, just so you can get all of this. So we sort of sought out to simplify this architecture so that we can even reproduce the errors, or maybe altogether be able to eliminate them, these errors that you reported. And we came to WebAssembly. And so WebAssembly is this sort of new kind of code that can run both in browsers, but also in Node.js. And it is essentially a low-level assembly-like language that is by default cross-platform. So once you compile it to WASM, you can run it on any sort of WASM-compatible device or runtime. And so this is all like really, really new technology. But the sort of great thing is that WebAssembly is really built and designed to run alongside JavaScript. And so, as I mentioned, you can browser, you can run it. I've seen an experiment running SQLite in the browser by compiling SQLite to WebAssembly. And because Rust is quite focused on good tooling to compile Rust into WebAssembly, and all of our engines are written in Rust, we were able to sort of make this radical transformation and then compile this Prisma format engine, which is essentially the Prisma linter, into WebAssembly. And that allowed us to basically simplify the extension significantly. And so you can see you don't have this child process anymore. You just have this sort of Prisma format WebAssembly module that is packaged together inside the NPM. And so you don't need all of this distribution infrastructure and compilation infrastructure, all of these build processes that take quite a while to run, and they have to compile for every target and then upload it. So it adds quite a lot of overhead. And so it both simplified our internal sort of processes around releasing these. And also we've already seen from, I think, a bunch of users since the release yesterday 2 days ago already, who've reported that their problems that were quite hard to reproduce have gone away. And so, yeah, I think this is a great success, and also really exciting, just because WebAssembly is a very exciting technology, and there's so many sort of opportunities for performance improvements and all sorts of things that could be done with it potentially in the future. And so, yeah, I'll wrap it up there. And if you have any questions, feel free to drop them in the comments.
Nice. Thank you for that overview. That was super informative. And actually, I have one quick follow-up question. And that came to mind because we are talking here about one of the engines that we're building, the Prisma formatting engine that's used in the VS Code extension. But of course, we have several further engines, right? Such as the query engine, such as the migration engine. So we are effectively always powering the actual functionality of Prisma with a certain like engine that's implemented in Rust. Do you know anything about whether it would make sense for us, or whether that's even planned to also port the other engines to WebAssembly eventually and make that process also easier?
So it's a great question, and probably worth pointing out. Why did we start with Prisma FMT? So here I have the Prisma engines, and it's probably worth pointing out we have this query engine. The query engine is the one that actually runs alongside your Node.js process, and that is the one that is responsible for connecting to the database and sort of handling all of the querying. Migration engine is for all the logic related to generating migrations and migration history and the shadow database. All of that magic is in the migration engine, and then we have the introspection engine. So we have all of these, and what is unique about Prisma FMT out of these 4 engines is that Prisma FMT doesn't rely on network connectivity. It is just takes a Prisma schema's input, spits back a formatted Prisma schema, and some feedback about that schema, whether it was good, bad, if there were any suggestions, and so on. And so there's no network connectivity. And because we rely on OpenSSL as one of the libraries that is actually statically linked within the Prisma engines, if I'm not mistaken, that introduces a whole set of complexity, making it a bit more difficult to compile into WebAssembly. And so OpenSSL is quite this beast, and it's required in order to communicate over TLS. So it has all of the logic for Diffie-Hellman key exchange, and like all of the crazy logic that goes into keeping the web secure. A lot of that is in OpenSSL, and I believe that it's not so simple to just compile it to WebAssembly. So this is sort of like me just riffing off what I know, but of course, I believe that there's obviously a push to investigate these things, not just at Prisma, but just more broadly. So I would say stay tuned.
Yeah. Cool. Thank you for this overview, Daniel. That was really, really helpful. And yeah, with that, I think we can move on to the next thing that we want to discuss today and chat about. And that's a chat with our Prisma ambassador, Albin, who has worked on the Prisma schema builder. So here he is. Welcome to the stream, Albin.
Hi, thank you so much.
All right, you have built a really nice tool, and that's the reason why we brought you on today. But before we jump into discussing that, why don't you tell us and our viewers a little bit about yourself and your background?
Yeah, sure. I basically have a background in design from the beginning. So I started out, in my teens with web design, app design, logos, all that stuff, and managed to land my first job at a startup where I lived. And then I quite quickly realized I liked the coding more. So that's really why I decided that's what I want to do. So then I basically just learned the rest at the job.
Very nice. So you are a designer turned into coder, basically.
Yeah, exactly.
All right. And would you consider yourself a full stack developer then, or like kind of where is your expertise?
Yeah, my expertise is definitely on front end, but I've worked on everything really. So
okay.
Yeah.
And where do you work right now? What kind of job do you have today?
Now I work as a full stack developer, focusing on front end at a startup in Stockholm.
All right. And how did you become aware of Prisma in the first place? When did it cross your path?
I think I've always kind of heard about Prisma, but never really knew what it actually was. And so finally one day I just decided now I'm going to figure out what it actually is. So I just dove into the documentation, learned about it, and my mind was pretty blown, to be fair.
Cool.
Yeah.
So you haven't used any other database libraries or any other object relational mappers before?
We used MongoDB at my first job, and with MongoDB, we used Mongoose, which I suppose is a ORM for MongoDB.
Yeah.
Exactly. So yeah, we use that.
Interesting. Yeah. Like on that note, we're also currently working on MongoDB support for Prisma, hopefully driving it towards general availability in the next few months as well. Right now, it's already in preview, so people can try it out. And we are always very happy about any feedback that people are willing to share on GitHub or on Slack, wherever you want to share this. What did you build with Prisma already before you then started building your own tooling to improve your own workflows with it?
Yeah, I've built a lot of side projects with Prisma. A lot of CRUD applications, notes apps, to-do lists, all that stuff, and some bigger applications too. And now I'm trying to get it into our work as well.
Okay, and out of curiosity, as a front-end developer, I think as someone who has their focus on the front end, and you now need a backend for your project, and you also have options like backends as a service, something like maybe Supabase or Firebase, maybe something like Hasura that also kind of generates an API for your database. Why did you decide to go with Prisma after all, having these alternative options that might seem to make it even easier for you as a front-end developer?
I think Prisma is kind of the middle layer between growing fully SQL or growing like Supabase or Graph CMS or something. You get some control, but you don't lose the productivity.
Nice. Cool. All right. How about you take us on a tour for the Prisma schema builder, and then I'll ask a couple of questions about it. But before we do that, why don't you just go ahead and give us a demo and explain a little bit what it is?
Yeah, sure. So I can start just by explaining why I built it. Maybe that's a good place to start. I think for new Prisma developers, and of course for experienced ones too, it can be a bit tricky to work in the schema file. There are a lot of new keywords and concepts that perhaps people aren't used to. So I thought it might be good to build a visual app for building a schema that you can just generate it there and then put it in your schema file. So I can do a small demo to show how it works.
Yes, please go ahead. And like on that note, I also want to mention that this idea of kind of visually creating your schema is something that has been floating around internally at Prisma for a while as well. So it's very nice to see actually this idea being picked up by a community member and just realized it on their free time. And also looking at our history as a company, we actually started out building a GraphQL backend as a service as well. That's way back 4 or 5 years ago. It was called GraphQL, where in fact we also had this visual schema designer where you would also just click together your models in a web-based UI. So I think that's kind of similar to what you've built now for Prisma. Very nice to see this initiative here. So yeah, let's share your screen here. And then you can give us a little of a demo.
Yeah, exactly. So once you land on prismabuilder.io, it's a pretty blank canvas, but the first step is to create your first schema. From here, you can basically just start adding your models. So we can do a quick demo of building a blog database. So let's start by calling our schema for blog. And we can call our first model user, for example. So basically we can see a model gets an ID by default. If we click on this, we can see how this is built up. Here we can see it gets a default value. We can change this to a UUID, for example. So we could go ahead and we could add an email field. tell this to be required and unique. And we can also do like a password. So now we have our first model here, and we can go
Very
ahead and
slick
create
UI, by the way.
Yeah, I'm actually using the Prisma lens library, React library.
Ah, okay.
Yeah,
this is our standard
with some
UI kit.
modifications. Yeah. So we can create our post model and add Bob, for example. And now we would want to have a relation between the post and the user. So if we go ahead and scroll down here, we can basically pick the user model as a field. And then we could call this author, for example. So yeah, we could create more models, but I think this is sufficient for the demo. So if we then go ahead and click on the Generate Schema button here, this is going to actually use the Prisma SDK to format it and create the relation fields, as you can see here.
Ah, very nice. So yeah, I noticed that you didn't specify the relation field on the user model, right? So now this gets inserted automatically. Yeah. And I guess this is powered by the same functionality that Daniel showed before when he was walking over the blog post when he showed how the relation fields automatically get inserted when formatting the schema, right? So it's the same kind of under the hood functionality that you're also harnessing here.
I'm curious, Albin, are you actually sending this to the backend so that you can run the SDK to format it?
Yeah, so the formatting is done by the SDK. The actual generation of the schema is a custom script that I found on GitHub by a guy called Richard. So it basically transforms from a JSON structure to the Prisma string, and you can actually do it reverse too. So you can paste your schema and then transform it into JSON. But it's nice. It's done on the back end.
Very cool. One thing that I noticed is that in the current version of this Prisma schema builder, you don't yet distinguish between different database connectors, right? Like, for example, if you were using SQLite, then it wouldn't be possible to use the big int type that you see on the right or the JSON type, I guess, because that's not supported by SQLite. Are there any plans on your end to make the Prisma schema builder here database connector specific in a way that maybe in the beginning you select which database you're using and then you get only shown the relevant data types?
Yeah, that makes a lot of sense. I didn't actually consider this when I built it, but I realized that it's not possible to use the JSON field, for example.
Okay.
So there are a lot of features to add.
At this point, we should probably also mention that this entire project, I believe, is open source, right? So in the bottom left, you have the button for the source code. So if people find this tool useful and they want to see new features, I guess one good way would be to just go ahead, dive into the code and build the features yourself if you're eager to improve this tool as well.
Yeah, that's one thing I would just want to push on a bit. I really want more people to join this project because I don't think I have all the right ideas here. I think Prisma has a big community, and everyone that wants to contribute should really join it.
Nice. You've heard it, folks. Check out Albin's GitHub and the prismabuilder.io repo, and you can help out. So I see a pages directory there, and that makes me suspicious. I wanted to ask about the tech stack. So I'm assuming you're Next.js. How did you architect the entire application?
Yeah, exactly. So I'm using Next.js. To be honest, I probably would have wanted to go with Svelte. but I didn't because Prisma, the Prisma Lens project doesn't have any svelte bindings, I think. So that's why I went with Next. So yeah, it's a Next application. All the data is stored in local storage, so there's no database involved. This is an active choice. Maybe in the future you could add a backend to this as well. Yeah, so that's basically how it's structured.
Okay, so no server side, like no backend at all. Everything is just running in the browser locally.
Yeah, there's one backend, like 2 routes for generating the schema and the formatting.
Okay, gotcha. So you're using like Next.js API routes for that?
Actually, I'm not using it because I tried using that and I ran into some issues with the Prisma SDK. So then I switched to using an Express server, and it worked fine. So something weird there.
Okay, gotcha. Is the Express server in a separate repo, or is that also like somehow
it's in a
here?
separate repo. You could
gotcha.
check it out if you want to.
Like maybe like we can drop a link to that also in the chat. We should also drop a link to this to like this repo. We can certainly do that. All right, what are the plans for future features that you want to build? I mean, we already talked about maybe specifying the database connector. Of course, you want more people to contribute, but is there anything that you really see as some things that you want to add in the near future?
In the near future, I would want to kind of reach a feature parity with the schema file. So I guess there are some default values that are missing. For example, here, I just picked the most used ones for me at least.
Okay.
So that's near term. Long term, it would be really cool, as I saw someone commenting in Slack, that perhaps you could click a button and this would generate a Prisma Cloud project with the schema. That's a cool feature.
We're getting close again to the workflows from GraphQL back in the day, because that would then be very similar. If you also had kind of an like an API automatically deployed, a database like provisioned alongside this, then like we're getting back to that. But I think this would be super useful, because actually this was one of the things that people really, really loved about GraphQL, that ease of getting started. You just like click together what your data models look like, and then a few clicks later, you have an entire backend basically ready. So I think this is a great opportunity for this tool to pick up and try to remodel this experience again.
And I just looked inside the API and I saw that it's using also pal.js in order to do the transformation to JSON.
Exactly. So that's basically for the importing only.
Nice. Yeah. Then big shout out to our community member Ahmed, who is the maintainer and author of pal.js and has done really great work on this tool.
So the view you're looking at right now is a view where you can visualize your relationships between your models. So for example, here you can see the author field on the post is a relation to the user model.
Very nice. Did you build this yourself, or like what kind of like libraries are you using for the visualization? Are you building on top of any existing like Prisma visualizer tools, or how is that generated?
Not Prisma visualizer. I'm using React Flow, I think, for like drawing the boxes and the arrows and stuff.
Okay.
Yeah.
Looks very, very nice, Albin. Great work. We have been sharing this internally, like once you have dropped it in the showcase channel in the public Slack, and everybody was pretty excited about it. So yeah, really great work. And thanks for coming on today and sharing all of this with us and our viewers.
Thank you for having me here.
All right, then enjoy the rest of your day, Albin. Cheers.
Peace.
Very nice tool. It's so great to see all of these helpful tools pop up in our ecosystem built by community members. And I'm sure that this will only increase in the future. So it's actually hard to keep up with all the great tools. And in fact, there were like maybe 2 or 3 other tools that have been released recently that we could probably also talk about on this show. So for example, there was one person that was building their own Prisma attribute for the Prisma schema to encrypt and decrypt certain Prisma fields in the database. That seemed super useful. I think their name was Francois, if I remember that correctly from Twitter. Then there was another tool, the Prisma event dispatcher. Maybe we'll talk about these tools at some future episode.
Yeah, that would be great.
All right, moving on. For those of you that have missed the Prisma Serverless Data Conference, and in particular the keynote that we have created for it, there were a couple of things in the keynote that we highlighted about the Prisma Data Platform, about the features that it already has today, but also about the ones that we want to build going forward. And we want to have feedback for these features, and we want to know whether you all find it useful, find the ideas useful. And so we have 2 particular features. One of them we're going to introduce today. And if you're watching this, you can leave us your feedback either here on GitHub. You can come on Slack and get in touch with our product team there directly. And also on our website, prisma.io/data platform, you can subscribe to updates for these new features. So let's check out the part from the keynote that introduced the idea of data projections. This is going to be a 5-minute clip, so we'll just watch it together here on the screen now.
As developers, we know that search is a solved problem. We introduce a dedicated search database such as Elasticsearch or a search service like Algolia. Then we ensure to write the product name and description to the search database so that we can leverage the advanced search functionality to deliver a better user experience and solve the problem. Right? Well, no. Unfortunately, it's not that simple. As soon as we start making updates to more than one database, we run into the dual write problem. We all know that a network request or an application can fail, and it's important that to make sure that when this happens, we don't leave an inconsistent state behind. When working with databases, we can normally depend on transactions to take care of this. But transactions only work in the scope of a single database. So in this scenario, what could happen is that a new product is added to the application database, but before it's added to Elasticsearch, the application fails. This means that the new product isn't searchable, although it's available. The solution to this problem is to write to the primary database and have the data propagated to the search database in a consistent manner. A popular way to achieve this is using the change data capture pattern. The industry standard for implementing this is called Debezium, which is built on top of Apache Kafka. We are looking to extend the Prisma data platform to support this pattern in a way that is optimized for serverless applications while still being compatible with industry standards. Okay, that was a lot of theory. What I'm about to show you is a very early concept of how we expect this to work. So keep in mind, while the syntax is just an example, we want the overall flow to be very close to the final product. If this sounds useful to you, then we'd love to hear from you so that we can make sure to incorporate your ideas and requirements into our final design. Okay, let's jump in. Here's a simplified Prisma schema showing the models relevant for this example. The first step is to introduce a new data source along with the product search index model in the Prisma schema. We'll use Elasticsearch in this example, but you can imagine doing this with your favorite search service. Note that Prisma currently only supports a single data source, but connecting it to multiple data sources is something we're considering adding soon. With this, You could already implement the dual write pattern by manually updating the data in both databases. But as we discussed, we need something better to avoid data inconsistency. Now, we want to take data from the first data source and project it into this new Elasticsearch index. We'll do that by defining a projection that is responsible for propagating changes. With this syntax, we define that the values of certain fields in the product model should be automatically propagated to the product search index in the Elasticsearch database. Under the hood, the Prisma data platform takes care of all the plumbing so you can focus on your business logic of your application. With these changes, I can now create a new pull request that contains this data projection. Creating the PR will trigger creation of a new preview environment. However, our preview environment creation will fail since we haven't defined our connection details to our Elasticsearch database. So let's go ahead and do that. Any project on the Prisma data platform has the ability to define multiple environments so that this is easy to customize settings for these. We can now go ahead and define the new preview environment variable to fix the problem. Now we're all set. The PR is green. We can go check out the details how this works by clicking on details. In the project view, I can look at the data projection I just added. And then I'll trigger the backfilling of existing data into the product search index. We can check out the backfilling happening here and verify that the data is being pushed into Elasticsearch with every change. And with that, our search issue from earlier is resolved. We can now rest assured that the search works and we don't lose revenue or hair over this. So let's recap what we've been envisioning here. With a couple of changes on the Prisma schema, we would be able to create data projections across data sources almost instantly. This allows you to forget about the infrastructure components needed to make this happen. Prisma would provision, operate, and monitor the infrastructure needed to make this happen, namely the components required for the change data capture pattern, as well as the persistent queue for offering a fully integrated alternative for Debezium and Kafka. This would guarantee that the application and search databases are always in a consistent state and enable straightforward backfilling when the data projection is deployed. You can imagine other usages for this, like building real-time subscriptions, projecting results of a complex query to a caching layer, or projecting data to a reporting system. Now,
all right.
CDC.
Yeah, huge thanks also to our colleague Alex, who did a great presentation of this feature. I think that looks really, really exciting. And one thing that I actually also like about this is that for us to implement it, it'll be a forcing function to also implement multiple data sources in the Prisma schema, which is a very, very commonly requested feature. And just think about the opportunities and the possibilities that there will be when you will have a single Prisma schema file and you can define models that live in different kinds of data sources. And ultimately, you would end up with a Prisma client API that's type safe and that allows you to query in a type safe manner across different data sources. So that sounds super exciting. And this is just a very nice kind of side effect, I think, of this feature when we're building it.
Yeah.
All right, I dropped the link to the Prisma Data Platform website in the chat, and on the chat you find, like on that page at the bottom, you find the buttons where you can subscribe to updates for this feature. So hit that button if you're interested in this. All right, Daniel, to wrap up today's stream, I think we wanted to talk a little bit about the public roadmap and some things that we have been working on and that are upcoming. Do you maybe want to share your screen again and show our viewers what we are working on?
Yeah, absolutely. All right, so here we have the public roadmap. You can find this at pris.ly/roadmap. We'll also drop a link in the comments. And I just wanted to point out and sort of summarize all the things that are currently in early availability. So they're preview or early access. And so we recently introduced introspection, the full text search API, that's for Postgres. Now you can define, the full text indices in MongoDB and MySQL. We have the interactive transactions, MongoDB index management with the Prisma DB push command. You can create multiple environments for a single project in the Prisma Data Platform. We have the Prisma Data Proxy. We've spoken a lot about this. The query console. There's also ongoing work on Nexus Prisma. Some of you have pointed this out. And so there is active development on that. We were just wrapped up with a lot of the Prisma Data Platform work for the serverless conf, and now we're giving it more love. And of course, support for Prisma in Cloudflare workers. But some of the really exciting stuff that we have coming up is MongoDB embedded documents. This has been a long requested feature to really fully unleash the power of MongoDB. We're also working on improving support for CockroachDB. If you haven't heard of Cockroach, it's another great serverless database that is built by some former Google employees. And I suggest you check out the talk at Serverless Conf that they gave. And we're also working on improving the Prisma ORM with Planet Scale. And speaking of Planet Scale, stay tuned. I'm going to be doing a really interesting live stream with Taylor from Planet Scale. And what we're going to do is we're going to take the same project that I built for Next.js Conf, and right now it's using AWS RDS, and we're going to migrate it, hopefully with zero downtime, to PlanetScale, because PlanetScale has launched their new import service that uses the replication log. So stay tuned. That's going to be probably happening next week. Nice. And we're also working on adding additional index types. And for the Prisma Data Proxy, a lot of you have asked for this one, static egress IPs for the Prisma Data Proxy. And so this is really relevant if you are working in an environment or your app is deployed in, your database is deployed in a place where it needs to add a firewall, an explicit firewall to allow traffic in. And so we're working on providing you with these static egress IPs so that you can add them to your firewall rules and allow access from these IPs so that you can finally use the Prisma Data Proxy with your VPC. And so with that, I think that's mostly it. And of course, we have all of these other things that are planned, but I won't go into them for now. I think we can wrap up at this point, at least the roadmap stuff. Yeah. Is there anything that sort of sticks out for you, Niko?
I'm really excited about the embedded documents, I have to say, for MongoDB, since that's kind of the last major thing before we can release MongoDB for general availability. And at the same time, it's also the foundation to bring typed JSON types to other databases, which also a lot of people have been asking for, and I think will also be a very kind of powerful addition to working in the Prisma schema and with the Prisma client. So I'm really excited about this one in particular. And yeah, about MongoDB in general. I mean, this is one of the last big things that we have to resolve, and then MongoDB is going to be ready for production. After a long time in the works, we'll finally be able to close that GitHub issue that I think is one of our most popular ones. So stay tuned, everyone. It won't take long anymore.
Yeah.
All right. We didn't really have any questions in the chat, just a lot of goodwill and nice compliments from people. So like a couple of shout outs. Victor shared his story about how he migrated over from TypeORM and really loves Prisma. I think Bello was excited about the data projections demo that we showed. So thank you all for the nice comments in the chat, and hope to see you again in 2 weeks at the next episode of What's New in Prisma. Cheers, everybody.
Ciao, ciao.